Augmentation rule says that if x determines y, then xz will determine z. That means you added z at both sides, on both sides. Okay, here you added z, here you added z, so it becomes xz determines yz. So this is augmentation. You augment any attribute with both sides, that will be valid. Okay, this is augmentation rule. And the third one is transitive rule. Fine. It says if x determines y and y determines z, then x determines z. This is the transitive. X determines y, y determines z, then x can determine z. This was the example here. Here this is x, this is y. Okay, y determines, say, z, then x can determine z. So this was the example of one example of transitive dependency. We'll see further examples in this, using this. Another rule is decomposition. Decomposition rule, or this is also called projective rule. Okay, this says that if x determines yz, then x determines y. That means you removed one attribute from here, z is removed, this is then. Okay, if this, then this. Right? This rule also is a inference rule called decomposition rule. Next is union rule or additive rule. Okay, this is if x, y, x, z, if this is true, then this will also be true. That means if x is determining y, x is determining z, then x can also determine combination of y, z. Okay, this we can prove. This we'll see how it is formed. The last rule is pseudo-transitive rule, which says if x determines y, wy determines z, then wx determines z. Okay, the proofs are there in the book, you can see once. Okay, these are the 6 rules. There is some importance of these 6 rules. See, the first rule says reflexive, second is augmentation, third is transitive. Okay, out of these 6, the first 3 are called Armstrong axiom. IR1, IR2, IR3. These 3 are called Armstrong axioms. Okay, what is this Armstrong axioms? Means Armstrong's rules. Using these 3, you can derive IR4, IR5, IR6. Means the other 3 rules can be derived using these 3. Okay, you see one example here. Suppose I am saying IR4, inference rule 4. It says if x determines yz, then x will determine y. How you prove it? It says if x determines yz, then x will determine y. Okay, so let's prove it. uh, Say yz determines y. See, this was given, now I am trying to derive this one. Okay, how do you do that? Now use reflexive rule. Reflexive rule says that if this is x and means this side is x, any part of this, either it may be y or z, can be determined by this, because this is a subset. Y is a subset of y and z. Y is a subset of y and z, so yz can determine y, yz can determine z. This will be true as per the reflexive rule. You remember here, reflexive rule says if y is a subset of x, that means if y is a subset of the left side, then this will be true. So this is reflexive rule. Here you see y is a subset of left side, here y was there, so y is a subset of yz. This will hold true as per the reflexive rule condition. So you are using here reflexive rule 1. Now what you got? X is determining yz, that is previously given. This is z. Okay, this was given, this you derived, that is yz can determine y. Now you apply IR3 transitive rule. X determines yz, yz determines y, then x can determine y. Got? This was the transitive rule which says that if x determines y, y determines z, then x can determine z. So the same thing you applied here. X determines yz, yz determines y, so x can determine y. Got? This you are trying to prove. So now it is proved. Okay, so IR4 which said this is actually derived based on IR1 and IR3. Similarly, if you see the other proofs, IR5 and IR6 will also involve either I1 and IR2 or I1 IR3. These through involving these three, these two also can be proved. Okay, so that's why Armstrong axiom says that these three rules are these three rules are sound and complete. Armstrong axiom is termed as sound and complete. These are mostly asked that why Armstrong axioms are called as sound and complete. Sound because if given a functional dependency set, okay, from that any possible other functional dependencies you can derive if you apply these three, IR1, IR2 and IR3. Any, if a given functional dependency set consists of suppose three functional dependencies, you can derive some other functional dependencies from that, maybe suppose, then all of them can be derived using only these three. No need of using IR5, 6 and 4. You can derive using IR1, IR2 and IR3 all the functional dependencies that are possible from the given functional dependencies. That's why this is called complete. Okay, complete. Now what is sound? Sound means whichever functional dependencies you derive, that will be valid for entire R. That means for all the possible rows that may be there in the relation, for all this functional dependency will hold true. Okay, that means suppose initially you have suppose two rows. Initially you have two rows. A third row is coming, which will be violating. Suppose x and y are here. There is functional dependency between these two attributes. Suppose for these two rows, these are valid. There may be another row inserted which may not hold this functional dependency true. But if the functional dependencies are being derived using these inference rules, these three Armstrong axioms, then any possible insertion will be obeying the functional dependency. That means this functional dependency will hold true for all. Okay. That's why this is called sound and complete. Fine. Now next thing is cover of FD. Okay, before we go on to cover of FD, there is another concept, closure of attribute X. That means there are two things. Previously we saw closure of function dependency set. That means if a function dependency set contains some functional dependencies, you try to derive other functional dependencies that can be derived using inference rules on these functional dependencies. That will be formed the function dependency, that will be forming the closure of the function dependency set. Similarly, there is a concept called closure of attribute. Okay, closure of attribute X depending upon or based on some functional dependency set. Don't confuse this. These are two separate things: closure of function dependency set and closure of attribute X or any attribute. These two are two separate things. Say you have a function dependency set. Suppose a function dependency set contains these function dependencies: SSN, ename, p number, p name, p location, hours. Suppose these three, sorry,